Sherry Davis's son Roger was only 5 years old when he started showing symptoms of a disease that would later take his life. It took months before a diagnosis was made. Finally, his parents were told that he was suffering from mitochondrial disease, an incurable condition that is passed from mother to child and can often be fatal. Roger's condition worsened, but before he could get an organ transplant, he died at the age of 8. Sherry also has a 3-year-old daughter, Sandy, who is currently showing symptoms of the disease. In spite of the gloomy outlook, Sherry's hopes of tackling mitochondrial disease have been raised by a procedure known as mitochondrial replacement. Sensationalized by the media as three-parent IVF, mitochondrial replacement involves modifying an embryo to replace the bad mitochondria with functioning mitochondria from a donor. Additionally, with the introduction of Prop 44 on the upcoming November ballot, mitochondrial replacement has been pushed into the spotlight as a radical technique that could rid us of mitochondrial disease once and for all. While mitochondrial replacement offers hope in an otherwise bleak situation, many warn that we must think of the big picture and explore the ethical, legal, and social implications the passing of Prop 44 would bring about. This and more in the following segment of 60 Minutes. This is Dr. Shapiro. He is a medical doctor and researcher at Newcastle University. There, he and his team have developed a technique called mitochondrial replacement. They believe that this is the most effective technique in dealing with mitochondrial disease. How would mitochondrial replacement remedy mitochondrial disease?
Our current intervention includes symptom management. However, 15% of the mitochondrial diseases are maternally inherited. So what we do is we replace the mitochondria before the embryo is implanted. It's similar to IVF in terms of the techniques involved. However, the technique we use, which is pronuclear transfer, which is developed in my lab, is somehow controversial because it involves destruction of embryos.
Has it shown promise?
Scientists at Newcastle University and Oregon Science and Health University have experimented in mice and monkeys. So the Oregon researchers used monkey eggs and they turned out to be fine. When born, no mutated mitochondria from the intending mother were detected. Their growth is monitored monthly, and at age 2, they are currently no different from the experimental controls. Scientists at Newcastle had similar success.
So this sounds great, but what's the holdup with this procedure?
Current laws in the US and UK do not allow the implantation of genetically modified embryos.
This is Sherry. She became one of the leading advocates for mitochondrial replacement after the death of her son Roger. Sherry is also the mother of Sandy, a 3-year-old girl affected with the disease. She is currently campaigning for several policies favoring mitochondrial replacement. One of these policies is Prop 44, which will be on the November 2014 state ballot. You're just surrounded by mitochondria from home to workplace.
Definitely. It's really hard. My son passed away from mitochondrial disease, and my daughter's developing symptoms as well. So as soon as I leave home, I'm working hard to get Prop 44 passed this November. I've read thoroughly about the disease. I've studied it. I've attended conferences. It's really tough, but I have to do it for Roger and Sandy and to make sure that no one else has to be affected by this disease.
So how bad is this disease? How is it affecting your daughter?
So unfortunately, she's beginning to show the same symptoms that Roger did. So general fatigue, hearing loss, organ failure. You know, as a mother, you can't help but feel guilty for passing on this horrible disease to your children. And that's why I'm an advocate for Prop 44 and for mitochondrial replacement in general. I want to make sure that my future children and no other children have to deal with mitochondrial disease.
So what is Prop 44?
So as you know, screening for mitochondrial disease is already required for women of reproductive age. So Prop 44 is just going to take this to the next logical step. to make sure that women who are at high risk for transmitting mitochondrial disease are reproducing responsibly. So if voters approve Prop 44, women at high risk for passing mitochondrial disease onto their children will be required to undergo mitochondrial replacement procedures to reproduce to save their children from the symptoms of the disease.
This portion of 60 Minutes is sponsored by Invesco.
On Tuesday, millions of Californians will vote yes on Proposition 44 and keep science moving forward. I want to thank you for being one of them. Do your part by voting yes on Prop 44 and save millions of children from the suffering of mitochondrial disease. Voting couldn't be more easy or more important. Just make sure you're informed by visiting www.mitochondrialtransfer.wordpress.com.
However, certain groups are less optimistic than Sherry about this procedure. They acknowledge the benefits of mitochondrial replacement but warn of the potential consequences. Take Jennifer Mitchell. She's a program associate for the Center for Genetics and Society, a nonprofit public affairs organization based in Berkeley, California. They focus on the responsible use of science and reproductive and emerging technologies. They believe we should think hard before voting for Prop 44.
We have concerns with designer babies and eugenics, but the underlying issue is that it also affects the germline. Mitochondrial replacement would make changes in every single cell of a child born from the procedure. Even more, these genetic changes will be passed on to subsequent germlines of children born from mitochondrial replacement.
So this procedure affects future generations?
Definitely.
How so?
This isn't like gene therapy, which modifies a specific location in the genome of the patient. It's not merely IVF to help two parents conceive a child. What's at stake here is much broader. The modification of a germline, the inheritable genetic code that connects humanity from one generation to the next. Are we willing to genetically modify future generations of humans? It's not natural, and it's stripping those affected germlines of their humanity, their identity.
So it affects the future germline, but that germline won't even exist if not for mitochondrial replacement. Without treatment, they might not even live?
Yes, but how confident are we with the possible long-term effects of this procedure? The experiments done on mice and monkeys were controversial. Furthermore, humans will be very different. They take longer to develop, so it's not until adulthood that we are entirely sure of its safety. Just think of that poor patient growing up, enduring endless medical testing, poking, prodding, and whatnot. I'm not sure parents are comfortable subjecting their children to that degree of experimentation.
To find out more about mitochondrial replacement therapies, visit mitochondrialtransfer.wordpress.com.